Okay, my dear, so now we're going to go to independent versus dependent events. So we kind of talked about this yesterday. Independent events are events that do not depend on each other. Dependent events are events that do depend on each other. So yesterday we were talking about replacement. What are the probabilities of choosing a marble, replacing that marble, and then choosing it again? Or what's the probability of rolling a 6 and then rolling a 3? So each time I kept repeating, our denominator isn't changing. So now we're going to look at probabilities where our denominator now does change, because we're not going to necessarily replace a card or replace a marble, changing our sample space the next time we draw a card or draw a marble. Okay, so if we think about independent events that do not depend on each other. So for example, that would be like rolling a die. Okay, so when we roll a dice, when we roll a die, or a die, each roll does not depend on each other. So the first roll doesn't care about the second roll. And the second roll doesn't care what you got on the first roll, because you're not changing the die. Another thing is like flipping a coin. The second flip doesn't care about what you got on the first flip. Okay, so these are things that are independent events. Okay. I apologize, my dog is next to me right now. That's what you just heard. Okay. So, let's go here. Now, dependent events do depend on each other. So, for example, if I have a bag of marbles, let's say I have a red one, a yellow one, a blue one, and a green one, then the probability of me getting a red one is different if I don't replace the red one. Okay, so the probability of me getting a red marble is going to be 1 out of 4, because there are 4 outcomes I could get, and only one of them is red. But let's say I don't replace it. Okay, so now that red marble isn't there anymore. It's over here. I picked it. Now what's the probability of me getting another red marble? Well, now it's 0 out of 4, because I didn't replace it. So this a lot has to do with without replacement is what you're really going to see. Okay. Oh, my handwriting's not great on this. I'm sorry. I'm trying out a new pen. Okay. So let's read each situation below and determine if it's independent or dependent. Flipping 2 coins results in 1 landing heads and 1 landing on tails. So, did the 2 coins care about each other? If the first coin landed on tails, was the second coin going to land on heads? Think about the coins themselves. If you're flipping 1 coin, does it change the outcome of the second coin, or vice versa? The answer is no. They don't care about each other. So it's independent. They don't depend on each other. The captain of the football team is selected, and the co-captain is selected. So, okay, if we have maybe Jazz Marie on the football team, we have Dylan, we have Felicia, and we have, I don't know, Michael. Okay. Then, if the captain is chosen, let's say we choose Felicia as the captain. Okay, Felicia's now the captain. Now the co-captain is selected. Does that change who's available for the co-captain? Well, it does, because now Felicia is no longer available to be co-captain. So instead of having 4 people in our sample space, we have 3 people because Felicia's now the captain. So this does depend, because you can't be captain and co-captain at the same time. You draw a joker from a deck of cards, and then you draw an ace. Well, let's see. Do we replace it or do we not? Well, if I draw a joker from a deck of cards, so there are 52 cards, and then there are 2 jokers. Oh, jock. Jokers. That's 54 cards in our sample space. But if I draw a joker and I don't replace it, now I don't have 54 cards anymore. Now I have 53 cards. So my sample space is going to change. I no longer have that joker in it. That means that my ace is now 1 out of 53 cards, whereas before it would have been 1 out of 54 cards. So this is dependent. It depends on whether or not I replace that joker. Drawing a queen from a deck of cards, replacing it, and then drawing a 10. Well, since I replaced it, my sample space is going to stay the same, right? My deck of cards is 52 cards. I draw a queen, and then if I replace it, and then draw a 10, then I'm going to have 52 cards still. So that is an independent event since I am replacing it. So if a coin is flipped and a number cube is rolled, well, a coin is heads and tails, right? A number cube is 1 through 6. Does the number cube care what the coin flip was? Like, is the number cube, that die, when I roll that die, is it going to care and change whether or not I got a heads or a tail on that separate coin flip? Okay, you know that it's not going to care, right? So that is an independent event. Okay, take a second, write that down. Okay, so let's move on to some examples. What is the probability that you roll a 6 on a die and then roll a 3 on a die? Well, rolling a 6 on a die, remember our sample space, ooh, my hand, is 1, 2, 3, 4, 5, and 6. So probability I roll a 6 on a die and roll a 3 on a die. Probability of a 6 and the probability of a 3. And then what does and mean again? And means multiply. So probability of a 6, I have 1 out of the 6 outcomes. Probability of a 3 is 1 out of 6 outcomes. Multiply those, because it's and. 1 times 1 is 1. 6 times 6 is 36. That is the probability of a 6 and rolling a 3. Now let's look at this marble. What is the probability you pick a red marble, do not replace it, and then pick a blue marble? Let's draw this first. I'll have a red, red, a red, a blue, a blue, a blue, a yellow, and a green. So let's see, my sample space is, we have red marbles. I drew 1, 2, 3 red marbles. Blue marbles, we have 3 blue marbles. There are 2 yellow marbles, and there is 1 green marble. So in total, there are 9 marbles. So what's the probability I pick a red marble? Well, the probability of a red is 3 out of 9, which is a third. Remember, we always simplify. Now, we're not replacing it. We're not replacing it. So essentially what that means is one of these red marbles is now gone. Right? That red marble is now over here. So now I want to pick a blue marble. Probability of the blue marble, well, I no longer have 9 marbles. I have, oops, because now I don't have 3 red marbles, I have 2 red marbles. So this is now 8 marbles. So now my probability of a blue marble is 3 out of 8 marbles. So the probability of red and then a blue, probability of red was 1/3, and means multiplication. And now my probability of blue, since I did not replace it, is 3/8. And I can multiply across 3. 1 times 3 is 3. 3 times 8 is 24. And I will get 1/8. So that is the probability of red and blue if I do not replace it. I don't know if you can hear, my dog is snoring. So let's keep going. Neil goes to the pet shop and selects a treat for his dog. He chooses one and then chooses another. What is the probability Neil selects a bone and then a ball? Okay. Now, he is not replacing it. He chooses one and then chooses another. He's not replacing, so no replacement. This is without replacement. Well, let's see. The probability of a bone is 1, 2, 3 out of 1, 2, 3, 4, 5, 6, 7. So there are 3 chances of getting a bone out of 7. So let's say he does pick a bone. So that bone now no longer exists. What's the chance of him getting a ball? Well, there are 2 balls left out of 1, 2, 3, 4, 5, 6 now. 6 items. Okay, we cross multiply. I'm sorry, not cross multiply, rather. We multiply across. So you can multiply across and get 6 out of 42, which can then be reduced. Or you can multiply on the diagonals, simplify on the diagonals. We can look at 3 and 6. What number goes into 3? What number goes into 6? Well, both numbers have 3 go into it as a factor. So we can cross simplify like this, and we'll get 2 out of 21, which is the simplified version. So either way, honestly, on the state test, I'd rather you just use your calculator. Don't waste time freaking out about, all of a sudden you forgot how to do fractions. Put in the calculator. It's your best friend. I care more that you don't get too stressed out on the test and that you're confident. If you understand how the setup is supposed to be, that's more important to me than whether or not you do the multiplication by hand. All right. Mackenzie chooses one candle and then chooses another candle. What is the probability that Mackenzie selects a polka dot candle both times? So, since she is choosing a candle and then chooses another candle, that again is without replacement. Okay, so she selects a polka dot candle both times. So probability of a polka dot candle, well, there are 2 of them out of 5 candles. What's the second time? So the second time, now 1 polka dot candle is gone. So now polka dot candle is only 1/4. So she has to multiply 2/5 out of 1/4 because there's only 4 after she chooses that first polka dot candle left out in the candles she can choose from. And she will get 2 out of 20, which reduced would be 1/10. Okay, so once you choose one of the items in your sample space, you can no longer have it in your sample space if they say they're not replacing it. They will explicitly tell you whether or not they replace it. I promise. Okay, guys, so let's go to this. Mrs. Moore is doing laundry and has various pieces of clothing in her laundry basket. So we're going to need to read the situations, determine if they are independent or dependent, and find the probability of the events occurring. So independent or dependent. Let's look at that first, okay? So what's the probability of selecting a top and then a bottom? So it doesn't say replacement, so this is without replacement. Meaning it's dependent. What's the probability of selecting a striped sock, replacing it, and then selecting another striped sock? Since they're replacing it, that means it's going to be an independent probability. What is the probability of selecting a towel, replacing it, and then selecting another towel? That means it's going to be independent. What's the probability of selecting a skirt? Oh, I'm sorry. My dog was barking. Okay. What's the probability of selecting a skirt and a top one choice after another? So one choice after another means that they're not replacing. This is without replacement. Which means it's dependent. And what is the probability of selecting a matching pair of solid socks, one choice after the other? Again, that is no replacement, meaning this is dependent. So let's try these now. What is the probability of selecting a top and then selecting a bottom? Well, let's find our sample space first. So we have, let's do our tops first. Our top, here's one top. That's it. They only have one top. Okay. So one top. So for the top, she has one. Let's do pants. 1, 2, 3, 4, 5, and I'm not sure if this is a towel or if this is like maybe a long skirt. I want to say it's like a very long skirt. 6. Okay. So there are 6 bottoms. Actually, you know what? I think it's a towel. Hold on. Let me erase this. So for bottoms, there are 5 bottoms. There's 1 towel. And there's 1, 2, 3, 4, 5, 6, 7, 8, 9 socks. Let's also talk about the pants, huh? So the bottoms are made up with, there are 2 skirts and 3 pants. So 2 skirts and 3 pants. For the socks, we have striped and we have kind of like blank ones, right? There are 1, 2, 3, 4, 5 striped ones, and there are 1, 2, 3, 4, blank ones. Oh, I wrote 2. Why did I write 2? Okay. So in total, we have 1, 2, 3, 4, 5, 6, 7, plus 9. We have 16 items. And if you want to go back and check that, we can just count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 items. Yes. Always write out your sample space. I know it takes a while, but it's worth it. Now, what is the probability of selecting a top and then selecting a bottom without replacement? So, probability of selecting a top. I'm going to do a different color. Probability of selecting a top. Well, we have one top out of the 16 items. But once we have that top, it's no longer in our item list. It's no longer in our sample space. So this changes to 15 items. Okay? So now we have to have how many in our bottom? For our bottoms, the probability of bottoms would be 5 out of what's left. Well, we only have 15 items now. And now we're going to multiply because it says and. 1 over 16 times 5 over 15. Okay, I want you to plug that into your calculator and see what you get. And you should get 1 over 48. Okay, that's a 48. Okay. I know you can't ask questions like on YouTube, but you can message me on Remind if you need more help, okay? What is the probability of selecting a striped sock, replacing it, and then selecting another striped sock? So the probability of a striped sock would be, well, there are how many striped socks? There are 5 striped socks. Out of the 16 total items. Now I'm replacing it, so my denominator is going to stay the same. So the probability of a striped sock the second time is is no longer 5 out of 16 though, because we're picking one of these socks, right? So now it's actually 4 out of, we are replacing it. I read the problem wrong. We're replacing it, so it's still 5 out of 16. So now we're going to multiply 5 out of 16 times 5 out of 16. Okay. Plug that into your calculator, and you should get 25 out of 256. Which cannot be reduced more. Now, what's the probability of selecting a towel? Oh, I knew it was a towel. Okay, the probability of a towel, replacing it, and then selecting another towel. So since we're replacing it, our denominators are going to stay the same. Okay, so the towel there's only 1 out of the 16 items. We're replacing it, so it's still 1 out of 16, the probability. And now we're multiplying it. 1 out of 16 times 1 out of 16 is 1 out of 256. That's not very likely, right? When you think about it, it's 16 items, and pulling out a towel randomly twice after replacing it is 1 out of 256 chance. That's not a lot. All right. What is the probability of selecting a skirt and a top, one choice after the other? That's without replacement. So the probability of a skirt is, let's see, we have 2 out of 16. The probability of a top, now since we're not replacing it, our denominator is no longer 16, it's 15. I have chosen, let's say, this skirt. Okay, so now the probability of a top is I have 1 top out of 15. So now, remember, it's and because I want to pick both. And so we'll have 2/16 times 1/15, which, by the way, this can be reduced. We can get 1/8 here, right? And so we'll have really 1/8 times 1/15. That should be 1/120. Okay, that's our probability of a skirt and a top without replacement. And our last problem, what is the probability of selecting a matching pair of solid socks? Well, a matching pair, meaning both of them are solid socks. So probability of a solid sock, or a blank sock, as I said it. Let's see. Well, let me take this skirt back. We're starting over. There were 4 blank socks out of the 16 items, which we can reduce to 1/4. And the probability of getting a second solid sock, well, we're not replacing it, so now our denominator is 15, and there were only 3 solid socks left since we chose one. So that's going to be actually simplified to 1/5. Ooh. So we're going to multiply them because we want both. It's an and. We should get 1/20, which is actually a pretty good chance. It's way better of a chance than 1 out of 256. Okay, so if you have any questions on this lesson, please feel free to message me on Remind. This is your homework. Okay, we'll check it. I will check it. Please let me know if you have any questions. Okay, guys, and have a happy Easter.